Welcome back to the course. In this video you will see how structured expert judgment may provide important input to safety and security studies. First, a general introduction will be given on safety and security science, followed by an enumeration of some important safety and security domains. Safety and security are often examined via its complement, risk. Some methods for quantified risk analysis will be highlighted, and the contribution of structured expert judgment to safety and security studies will be shown. Safety is the freedom from or the resilience against harm or other non-desirable outcomes. A safety scientist investigates the factors which influence the safety levels. Sometimes these factors can be intentional from hostile forces. Then we are referring to security studies, where malicious, intentional factors, attacks, vandalism, burglary, etc., influence the freedom from non-desirable outcomes. Otherwise, if the factors are random, non-intentional, then we refer to safety. A safety scientist examines the factors that influence the safety of systems, distinguishing a number of main factors: the technical factor, the human factor, and the organizational factor. A system can fail because the technology fails, a sliding dike, or people fail, a bus driver who falls asleep, or the administrative organization fails, the tour operator who schedules too tight schedules for his bus drivers. In addition, the economic factor to study safety from a cost-benefit framework is there, and the ethical factor to reflect on ethical issues surrounding risks related to loss of human life, privacy issues, and the like, also play an important role in safety and security studies. There are many safety and security application domains. The columns in this figure just show a limited selection of domains. Security in the cyber domain receives a lot of attention lately. Safety of people against natural hazards, such as floods, earthquakes, hurricanes, etc., is an important domain and strongly related to the structural safety of buildings and infrastructures, such as dikes and other flood defenses. Safety and security of traffic and transport in the multimodal supply chain, such as aviation, road, rail, maritime transport, is an issue. Although people perceive road traffic as quite safe, it is in fact one of the most dangerous domains in this list, with the highest number of casualties every year. Finally, industrial and nuclear safety is an important domain in order to protect people and environment against dangerous emissions. A safety and security scientist often investigate these domains by modeling the risks of the undesired events that can take place within these domains. For all these domains, a common methodology is adopted in which the following three questions are addressed. What are the probabilities of occurrence and the consequences of the undesired events? This involves data analytics and probabilistic modeling of historical observations of undesired events, as well as modeling the relationships with the factors which might influence these occurrence probabilities and consequences. How can the causal factors which lead to the occurrence of an undesired event be decomposed into subsystems? This will be further elaborated in a moment. And once the risks of the undesired events have been modeled, the overall question is whether the quantified risk is acceptable or whether further safety and security measures should be taken to reduce that risk, i.e. the management cycle. For each of these three questions, structured expert judgment provides important input, in particular at situations when sample sizes of empirical data are limited. An essential part of safety and security science is the methodology to estimate the exceedance probabilities of extreme events. A common approach is the annual maximum procedure, in which the data is fitted with extreme value distributions by statistical parameter estimation methods. Still, the extrapolation of the distribution functions to low probabilities is surrounded by large uncertainties, as can be seen from this figure, where 6 different estimation methods, shown by the colored lines, apply to the annual maximum river discharges of the River Meuse, shown by the small circles, for which we have about 100 years of discharge observations, show a spread in the 10 to the power minus 4 quantile of almost a factor 2. Expert judgment studies are helpful here to reduce this uncertainty to smaller intervals. Typical seed variables are quantiles with a relatively short return period, for which the true values are available post hoc. Failure can usually occur due to more than one single failure mechanism. This is true for flood defense systems, which can fail by a whole set of possible mechanisms as shown in this fault tree. The fault tree is an essential tool in safety and security science to model the causes of possible failure with Boolean logic. The fault tree is the left part in the Bowtie model. The right part in the Bowtie model is described with forward logic, the consequences appearing after the failure of a structure, system or process. There are some disadvantages of the Bowtie. The Boolean logic with AND and OR gates is deterministic, although causality is probabilistic. There's always a chance that a certain event does not occur, even if the conditions are fulfilled. This is especially true if human influence is involved in the system. Human influence is certainly not deterministic. A new sort of construct has been developed, known as the Bayesian Belief Network, BBN. Aviation processes now have reached such a degree of complexity that traditional analytical methods are no longer able to deal with the entire aviation system spectrum. A BBN model provides insight into the cause-effect relationships in the event sequences leading up to potential incidents and accidents. These event sequences cover all potential failure modes of the operations during the different flight phases. The model enables quantitative risk assessments of existing and new operations to be carried out while providing insight into the effectiveness and efficiency of risk-reducing measures. BBNs are currently also introduced in the chemical industry, and they represent a promising line of research with wide applications. Expert judgments are needed here for the prior probabilities of the root causes, as well as for the conditional probabilities of the cause-consequence relationships. Safety and security science is not only about technical and engineering issues, but also about human behavior and safety culture in organizations. Human errors, knowledge-based, rule-based and skill-based errors have a large contribution to the occurrence of failures. But also the safety culture in organizations can contribute. The safety ladder distinguishes pathological organizations, where the organizational culture manages to escape the work of regulators, to generative organizations, where health and safety is how we do business here. And management priorities, training of employees, protocols, etc. are factors which help to describe the safety culture in organizations. The effect of the type of organization on the performance shaping factors of human operators, for instance, is an important question for which empirical data is often missing and where structured expert judgments could step in. If you are interested in reading more about the application of structured expert judgment in safety and security studies, these are two interesting conference papers, where the paper by Ale et al. Shows the details of expert judgments in aviation safety, and the paper by Van Gulik et al. The details of expert judgment in industrial safety.